In 4000 BC, the first astronomers to make long-term written record, most lost or destroyed, of their observations were the Mesopotamians. They originated the idea of dividing the circle into 360 degrees. The astronomers were the timekeepers of their communities. Mesopotamian astronomers were able to do this because they had discovered that the groups of stars that rises just before sunrise changes with the seasons. In 1300 BC, the Chinese made observations of eclipses. They also recorded other conspicuous astronomical events, such as meteor showers, guest stars, and comets. Comet Halley was one of them in 466 BC. Ancient Chinese observations have been of great value to today's astronomers in their attempts to understand comets and exploding stars. The Babylonians accumulated records of astronomical observations for many centuries. Because of the records, they were able to see repeated patterns in the motions of the celestial objects. They used the patterns to predict the positions of the moon and planets in 1830 BC. Eratosthenes found the difference in the altitude of the noonday sun at Syene and Alexandria. He realized that this is the same as the difference in latitude of the two cities. This difference allowed him to find the ratio of the circumference of the Earth to the distance between Syene and Alexandria, 276 to 194 BC. Ptolemy's model of the solar system pretty much matched the motion of each planet and predicted its future position. At first, Ptolemy thought the Earth was stationary at the center, which means it's too heavy to revolve around the sun or rotate. Later, he found out it wasn't. After he fixed it, it was used for nearly 1,500 years, 100 through 170 AD. Tycho Brahe was able to make observations more accurate than those of any astronomer who had come before him. He carried out regular observations of the sun, moon, and planets for many years. His observations were a benchmark against which astronomical theories could be tested. He also created the Mural Quadrant, 1546 through 1601. Sir Isaac Newton, 1642 through 1727, was an English mathematician and physicist who invented calculus, formulated the law of gravitation, and discovered the laws of motion. Niels Bohr, 1885 through 1962. In 1913, based on Rutherford's theories, Bohr developed and published his model of the atomic structure, known as the Bohr model, which depicts the atom as a small, positively charged nucleus surrounded by negatively charged electrons that travel in circular orbits around the nucleus, similar in structure to the solar system, but with electromagnetic forces providing attraction rather than gravity. Edwin Hubble was an American astronomer who played a crucial role in establishing the field of extragalactic astronomy, and is generally regarded as one of the most important observational cosmologists of the 20th century, 1889 through 1953. Sir Fred Hoyle was an English astronomer noted primarily for the theory of stellar nucleosynthesis, but also for his often controversial stances on other scientific matters, in particular his rejection of the Big Bang Theory, a term coined by him on BBC Radio, and his promotion of panspermia as the origin of life on Earth, 1915 through 2001.
As far as we know, the Egyptians developed and used astronomy entirely for practical purposes, such as developing a calendar to be used for predicting the Nile flood and in aligning temples and monuments 3000 BC. The first of the Milesian astronomers was Thales. He went to Egypt to gather ancient knowledge. He is well known for predicting total solar eclipse. There was a war going on between the Lydians and the Persians, but quickly ended because of the eclipse. Not even the Babylonians could predict a solar eclipse. 624, 547 BC.
384 through 322 BC. Aristotle accepted the model of Exodus, but he modified it to include even more concentric sphere. Aristotle argued that all celestial motions must be circular because circular motion is the only motion that can be repeated forever and is suitable for unchanging bodies such as the moon, sun, and stars.
Hipparchus discovered a new star in 134 BC. Even though the most of his work vanished, descriptions say he gave positions and indication of brightness for about 850 stars. 700 through 1200 AD. Although the astronomical works of the Islamic world from the 7th to the 15th centuries were usually written in Arabic, many of the Islamic astronomers were Arabs.
1564 to 1642. After the telescope was invented, Galileo discovered 4 of Jupiter's moons almost 400 years ago. Although credited with inventing the telescope, he did not. He discovered many unknown stars and that the Milky Way's glow is actually a cluster of stars. 1656 to 1742. Edmund Halley was an English astronomer, geophysicist, mathematician, meteorologist, and physicist who is best known for computing the orbit of the famous Halley's Comet. 1900 to 1958. Wolfgang Pauli created work on spin theory and quantum theory. He also created Pauli exclusion principle, which underpins the structure of matter.
1894 to 1966. Georges Henry Joseph Edward Lemaitre was a Belgian priest and astronomer of physics at the Catholic University of Leuven. He proposed the theory of the expansion of the universe, widely misattributed to Edwin Hubble.
1964, Penzias and Wilson discovered cosmic microwave background radiation, also known as CMB, an ancient light that began saturating the universe 380,000 years after creation. And they discovered it on accident. This discovery is the predicted thermal echo of the universe's explosive birth. It put Big Bang Theory on solid ground. CMB is the oldest light in the universe. CMB supports the theory of cosmic inflation, which explains that the universe expanded much faster than the speed of light. CMB also contains tiny temperature differences, which shows areas of different densities. These fluctuations in density were the basis of what gave rise to stars, galaxies, and everything we see in the sky. People still make amazing discoveries based on CMB. The Stonehenge was by far the most famous prehistoric monument. The monument was built around 5,000 years ago. Astronomical observations weren't as advanced as to predict lunar and solar eclipse. It was very likely that it was a religious practice.
582 through 500 BC. Pythagoras and his students made scientific models that are a turning point. He was the one who said the earth is not flat and that the earth is moving and it revolves around the sun. 300 BC. Aristarchus used geometry for astronomy to measure the distance of the moon and the moon to the sun. Aristarchus proposed using lunar eclipses to give the relative size of the moon and the earth. Mayans and Mesoamericans, 1 through 1000 AD. Many monuments and buildings were aligned to the position of sunrise and sunset at the equinoxes and solstice. Many battles were dependent on Venus's position in the sky. They created lines of sight pointing towards Venus's northernmost and southernmost points. 1473 through 1543. Copernicus was the one to create the first fully developed heliocentric model of the solar system. Copernicus proposed that the sun is the center of the solar system. 1968 through 1969. Kepler made 3 laws. First law is that the planets move on elliptical paths with the sun at one focus. The second law says that a planet moves so that a line drawn between the planet and the sun sweep out equal areas in equal amounts of time. The third law says that the square of the sidereal period of a planet is proportional to the cube of its average distance from the sun. One of the most popular scientists is Einstein. He wrote a paper known as the theory of relativity in 1915, which states that nothing moves faster than the speed of light. Einstein noticed how light rays from distant stars appear to bend when going near the sun.
Werner Heisenberg was a physicist and philosopher who discovered a way to formulate quantum mechanics in a form of matrices. 1901 through 1976. Robert Oppenheimer's research was devoted to energy processes of subatomic particles, including electrons, positrons, and cosmic rays. Neil Armstrong and Buzz Aldrin were the first people to walk on the moon. The spaceship they rode was called Apollo 2. Armstrong was the very first person specifically to walk on the moon. His iconic words are, "One small step for man, one giant leap for mankind."